Over the past 4 years, I've literally soldered thousands of LED strips while making all these sculptures. During that time, I feel like I've ironed out a pretty good workflow that I want to share with you today. This video is sponsored by PCBWay. To make a good solder joint on an LED strip, there are 3 stages that I want to break down: preparation, soldering, and finishing. LED strips have cut marks indicating where to slice them, and my suggestion is to disregard them entirely. Instead, I want you to cut out a sacrificial pixel, giving yourself more copper to work with. Throughout this video, I'm going to be using the addressable NeoPixel LED strip, but the same principles will apply to any LED strip that you're using in your projects. Let's start out by tinning these pads with a nice mound of solder. Unfortunately, it's not quite as easy as painting with a big ball of solder. In fact, I can pretty much guarantee that technique won't work at all. Instead, the correct technique is to heat up the copper pad for a second or two and then feed in fresh solder. I did that demo a little fast, and there are some important steps that I don't want you to miss. So let's break that down again a little bit slower. First, I always have a small bit of solder on the tip of my iron for improving heat transfer. Second, I held the iron at a shallow angle. If held vertically, the contact area is very small, resulting in poor heat transfer. Third, I'm intentionally only covering half the copper pad with the iron. Once hot, I apply fresh solder to the copper right next to the iron. Touching the iron briefly to start melting the solder is okay, but the focus should be to apply solder onto the copper pad, not pooling it on the tip of the iron. When finished, I look for a round mound of solder. A thin surface layer is not adequate. Tinning wires is basically the same process. Add a small ball of solder to the tip of the iron, hold that ball of solder in contact with the wires for a second or two, and once hot, add fresh solder from the opposite side of the wire. The wire should be sandwiched between the solder and the iron. Assuming you twisted the wire into a solid bundle before tinning, you should have no loose strands sticking out. Also ensure that the solder covers all sides of the wire. To finish, cut the tinned wire to about the same length as the exposed copper pad. Now, if you don't want the hassle of stripping and tinning your own wires, you can reach for a JST SM connector. Not only do these cables come pre-tinned with the perfect length of wire exposed, but they're also universally compatible with off-the-shelf NeoPixel controllers and can quickly daisy chain between multiple sections of LEDs. But be aware, while traditional 2-wire LED strips can be powered from either side, 3-wire addressable LEDs only transmit data in one direction. This direction is indicated by an arrow, and in order to work, the controller must be positioned to send data in the same direction. To maintain consistency between devices, use the winged JST connector for data input and the other one for data output. The copper pads themselves are labeled with +5 volts for the red wire, D in for the green data input wire, and GND for the white ground wire. Now it's time to connect our pre-tinned wires and LED strips. When securing the LED strip, I find that the teeth on generic helping hands are too aggressive, so either wrap them in electrical tape or use smoother jaws. I like to clamp from the top of the first LED. Too far away and the strip will be flimsy. Alternatively, you can secure them to the table with a piece of tape or a heavy object. Don't forget to clean your iron every couple of minutes with a brass sponge. Then I'll add a little bit of solder to the tip of the iron for improved heat transfer. The goal is to position the wire so that it's in direct contact with the copper pad. Then bring the soldering iron in and melt both the solder on the wire and the copper pad at the same time. Once liquid, remove the soldering iron and hold the wire stationary for a second or so until the solder cools down and solidifies. If you move the wire too soon, the solder won't have time to solidify and the connection will break. If you're looking for any of the tools or materials shown in this video, I have links to everything down in the description below. If you want to quickly start out doing your own lighting projects at home, the bare minimum will be a 5-volt power supply, an off-the-shelf controller, and a 5-volt NeoPixel LED strip. If you follow the steps that I've just provided, you'll end up making a solid connection, and you can probably stop watching the video right now. But I encourage you to stick around for a couple more minutes because there are a few small but significant pitfalls to be aware of. When tinning, if too much solder is added, you'll get bridged connections. Fortunately, this is an easy fix. By melting the solder and dragging the iron between the bridged copper pads, we can cut through this undesired connection. On the flip side, inadequate tinning makes the connections difficult. Simply top up with more solder. If you bridge the connection while attaching the wires, no problem, simply desolder, reset, and try again. Note that both the wires and the strip are sensitive to excessive heat, and if you've been battling the same connection for a long time, they may be damaged. In this case, I'd suggest cutting back both the wire and the strip and then resetting from fresh. If at any point the solder isn't melting for you, I'm willing to bet good money that there isn't an adequate bowl of solder on the tip of the iron. Make sure the tip is never bare. And a secret technique is to consider which side of the copper pad you want to attach the wire to. If I solder the wire to the inside of the pad, I have less space to connect the next wire, as opposed to if I had positioned the wire on the outside of the pad. With our LED strip soldered up, we can go ahead and connect it into a controller. And this is great, but it lacks customization. That's where this video's sponsor, PCBWay, comes in. PCBWay offers an amazing fabrication service, enabling makers like you and me to get high-quality circuit boards with fast turnaround times. To create your own boards, simply click on Quick Order, upload a Gerber zip file, select your PCB preferences, and for just $5 plus shipping, I got 10 boards delivered to me fast. I can't imagine doing half my projects without the circuit boards that PCBWay helps me fabricate. And finally, here are some finishing tips and tricks. Sometimes you want to connect two LED strips. To do this, secure the strips on a flat surface and melt solder onto each of the neighboring pads, building it up until the surface tension barrier between neighboring solder globs is broken. Waterproof LEDs come with a cover that can be peeled back and expose the copper pads underneath. Once soldered, I'd recommend adding a little bit of silicone wrapped in heat shrink. And I always recommend strain relief for your cables. This can be as simple as a zip tie that ensures the solder connection doesn't rip off when the cable is pulled. Hopefully you've learned something useful in this video, and if you'd like something else to watch, I'd recommend checking out my other soldering tutorials. Don't forget to check out the video description for the materials I've been using, and I'll see you in the next one.